Hello everyone, good evening. So here we shall start from question number 64 onwards. So here it is told that the bisectors of angle B and angle C. So here is an isosceles triangle ABC with AB equal to AC, and the bisectors of angle B and angle C intersect each other at the point O. Then so that the exterior angle adjacent to angle ABC means this angle. Let's call it as ABP. So this angle should be equal to this angle in BOC. So that the exterior angle adjacent to angle BC is equal to angle BOC. So here first we will write what is given. So it is given that the bisectors. So it is bisector, it means these two angles are equal and these two angles are also equal. The bisectors of angle B and angle C when isosceles triangle ABC with AP equal to AC, AP equal to AC intersect each other. Intersect each other at the point of. Intersect each other at the point of. So we have to prove that exterior angle adjacent to ABC means angle. So here we can also say that CB is extended. CB is extended to the point T. CB is extended to a point T. So we have to prove that angle ABT, or I can say the exterior angle ABC. That should be equal to. So angle ABT that should be equal to angle BOC that we have proved. So the proof. So we will write the proof. So the proof is that we'll say that angle B equal to angle C, which is given okay. Angle ABC. Angle B equal to angle C is not given. AB equal to AC is given. So we will write AB equal to AC is given. And angle ABC that is equal to angle ACB. Since the angles opposite to the equal sides. Opposite to the equal sides of an isosceles triangle are equal. Angles opposite to the equal side of an isosceles triangle are equal. So therefore we can say that half of angle APC is also equal to half of angle ACB, which is equal to angle OBC equal to angle OCB equal to angle OCA equal to angle OBA. Since OB is the bisector, since OB and OC are the bisectors of angle B and angle C respectively, which has been given. It means all these angles are equal. So now, therefore, we can say that angle BOC, that would be equal to 180 degree minus angle OBC plus angle OCB. The reason is according to the angle sum property of a triangle. Angle sum property of triangle. Angle OBC let angle OBC we take as x degree. So then angle OCB is also equal to angle OBC, which is equal to angle OCA, which is equal to angle OBA, which is equal to x. Therefore, angle BOC, that would be equal to 180 degree minus OBC is also x, OCB is also x, so 180 minus 2x degrees. And now you can say that angle ABC plus angle ABD, angle ABC plus angle ABD, that is equal to 180 degree. Here's why it is forming a linear pair. Since it is forming a linear pair. So now angle ABC is twice of angle ABC, that is equal to 180 degree. Angle ABC, that will be equal to 90 degree. So this is angle ABC plus angle ABD. Angle ABC plus angle ABD. ABC plus ABD, that is forming a linear pair. And now angle ABC, that will be equal to angle OBA plus angle OBC. Angle OBA plus angle OBC. So that will be equal to 2x degrees. So we can say that angle ABD, that is equal to 180 degree minus angle ABC is equal to 180 degree minus 2x degrees. So therefore here we can see that angle ABD, that will be equal to angle BOC. So henceforth, then in question number 65 it is told that use a point on the bisector of angle ABC is a point on the bisector of angle ABC if the line through P parallel to BA meets. Yeah. So here it is told, so let this be angle ABC and P is a point on the bisector. The line through P parallel to BA. So if you draw a line which is parallel to BA, it meets BC at Q. To prove that triangle BPQ is an isosceles triangle. Now it is given that P is a point on the bisector of angle ABC. And if the line through P parallel to BA, the line through P parallel to BA meets BC at Q. So, and we say okay, and the line through P parallel to BA meets BC at Q. Okay. And then we have to prove that triangle BPQ is isosceles. BPQ is isosceles. So how to prove this? We will say that here this QP, so we'll say that angle PBA that is equal to angle PBC. Since why? Since BP is the bisector, this PP is the bisector of angle B. It is angle B, or I can say angle ABC, which is given. And this is so this is equal to half of angle ABC. And also, you can see that angle QPB that is equal to angle ABP. Since the reason is that since alternate interior angles are equal, alternate interior angles are equal, alternate interior angles are equal, and PBB is equal to PBP. Alternate interior angles are equal since it is given that EQ is parallel to AB, which is given, and BP obviously is the transversal. So therefore, I can say that angle ABB that is equal to also angle. Therefore, I can say that angle therefore we can say that in triangle BPQ, QQ, or angle QPP is equal to angle QPB. Is why PBC is same as PBQ1. PBC is same as PBQ. So these two angles are equal. These two angles are equal. Since both are equal to half of angle ABC, which is proved above. So therefore, we can say that therefore BQ is equal to PQ. Therefore, BQ is equal to PQ. Since there is a that since the sides opposite to the equal angles of a triangle are also equal. The sides opposite to the equal angles of a triangle are also equal. So I can say that triangle BPQ is an isosceles triangle. Triangle BPQ is isosceles. So hence proved. Then here it is told the image of an object placed at a point A before a plane mirror LM is seen at the point B by an observer at T. Observer at T, as shown in the figure, prove that the image is as far beyond behind the mirror as the object in front of the mirror. So simply it means that here first we will write what is given. So given is that um, the image of the object, the image of the object A is seen at the point B. When kept, when it is kept before a plane mirror, kept before a plane mirror LM by an observer T, by an observer at T. Then we have to prove that A and B are equally distant, or I can say as if the image B is as far from the plane mirror as the object is in front of the mirror. I can say simply the points A and B are equally distant from the plane mirror LM. From the plane mirror LM. Proof. The proof is given that proof will be given as so we can do some construction actually. We have to do these constructions. So the construction is the incident ray AC is drawn on the mirror LM such that the reflected ray passes through D. Reflected ray passes through the point D. So it means that CD is the reflected ray. Reflected ray. And DC is extended and also line segment BC is drawn. The line segment BC is drawn. And also NC, which is perpendicular to LM, is drawn at the point C. Drawn at C, at the point C, which is the point of incidence. The point of incidence. So it means that the proof is that angle ACM that will be equal to angle I, so the angle of incidence of incidence at the point C, and angle PCN that will be equal to angle R, which is the angle of reflection. Angle of reflection at the point C. So it means that angle ACN that is equal to angle DCN, since angle of incidence is equal to angle of reflection according to the law of reflection. The angle of incidence is always equal to angle of reflection, which is according to the law of reflection. So now therefore I can say that angle ACT. Right, here also we should say that A and B. Here also we can say and line segment AB intersects LM at T. So here we'll say that angle TCA that will be equal to 180 degree minus angle ACM. 180 degree minus angle ACM is equal to 180 degree minus I. And similarly, angle MCD, sorry, MCN, sorry, MCD only. Angle MCD, sorry, this is not 180 degree, this will be 90 degree. TCA, that is 90 minus angle 5. Since obviously CN is perpendicular to LM. And similarly, MCT that is equal to 180, 90 degree minus angle 180 degree minus angle MCD, 90 degree minus R. Since therefore we can say that angle TCA that will be equal to angle MCD, which is equal to 90 minus I, since angle I is equal to angle R. TCA is equal to MCD. And also angle BCT that will be equal to angle MCD. Angle MCD is equal to 90 degree minus I only. BCT that is equal to MCD. Since why they are vertically opposite angles. Vertically opposite angles are equal. So therefore we can say that CT that is equal to angle PCA equal to 90 degree minus I. Angles are same. The one side. Okay, so here angle BCT equals to angle TCA, that is equal to 90 degree minus I, and also angle BTC equal to angle ATC, that is equal to 90 degree. Since obviously AB is AB is perpendicular to LM at the point T, and AB intersects LM at T. So therefore now in triangle ATC, ATC and BTC, in triangle BTC, you can see that angle BTC, that is equal to angle ATC, that is equal to 90 degree, is proved above, and angle BCT, that is equal to angle ACT, BCT equal to ACT, which is equal to 90 degree minus I, is also proved above, and CT is the common side. CT is the common side. So therefore, I can say therefore triangle ATC is congruent to triangle BTC by A is a rule of congruency. A is a rule of congruency. So therefore, we can say that AT is equal to BT. Therefore, we can say that AT is equal to BT by CBCT. AT is equal to BT by CBCT. Hence, we can say that the image is as far behind the mirror as the object is in front of the mirror. So simply, I can say that, or we can say that the distance of the image from the mirror is equal to the distance of the object from the mirror. Distance of the object from the mirror. So hence proved. Then here in question number 67, it is told in triangle ABC, D is the midpoint. So I can say, so this is triangle ABC. Triangle ABC. D is the midpoint of AC. D is the midpoint of AC. So it means AD is equal to CD, such that BD is equal to half of AC. So it means this is also equal, so that angle ABC is a right angle. So it is given that in triangle ABC, AD, okay, triangle ABC, D is the midpoint of AC. D is the midpoint of AC, and BD is equal to AD equal to CD, D is equal to half of AC. And we have to prove that angle ABC is a right angle. Angle ABC is a right angle, or angle ABC is 90 degree. So the proof is, you can say that in triangle BTC, BD is equal to CD, which is here. So therefore, we can say that angle DBC, that is equal to angle DCD. Since why? The reason is that since angles opposite to equal sides are also equal, angles opposite to equal sides, the equal sides of a triangle are also equal. Also, in triangle ABD, and AB is equal to BD given. So now therefore angle ABD that is equal to angle BAD. Angle ABD is equal to angle BAD. Angle ABD is equal to angle BAD. Since why? Since angles opposite to the equal sides, angles opposite to the equal sides of a triangle are also equal. So therefore, now let angle ABD is equal to angle BAD is equal to x. Suppose x say, and angle DBC is equal to angle DCB is equal to y. Suppose. So now therefore in triangle ABC, I can say that angle A plus angle B plus angle C that is equal to 180 degree is the angle sum property. Angle sum property of a triangle. You know, angle A, it means it is angle BAD. Angle BAD is same as angle A only. Plus angle B will be, this is X, so this will be X. This is Y we have shown. We have assumed DBC equal to Y, so PCB is also Y. So therefore angle B will be equal to X plus Y, and angle C that will be equal to Y. Since angle C and angle DCB is the same thing, that is equal to 180 degree. So therefore I can say twice of X plus Y that is equal to 180 degree. So therefore X plus Y that will be equal to 180 degree by 2, that is 90 degree. So therefore I can say that angle B, which is same as angle ABC, that will be equal to X plus Y, which is 90 degree. So hence prove that angle ABC is a right angle. So hope all of you understood the solutions of all these questions till question number 67. Any doubts if you have, please write that in the comments. We shall obviously clarify them. So thank you everyone